So picking up where we left off on number 3, it says on all 3 routers verify that the loopback 0 interface IP address was selected as the router ID. We confirmed that on BB router 1. We've seen that it has the IP address of 11.11.11.11. So let's go ahead and move on to BBR2. Let's do a do show IP OSPF, and enter. And we can see that it has the IP address of 222.222.222.222, which is what we wanted. Let's go ahead and move on to router 1. And we can do a do show IP OSPF over here. And we can see that it has the router ID of 1.1.1.1. And we configured all of these router IDs on our loopback 0 interfaces earlier in the lab. So number 3, we just answered that. We verified that actually. So let's go ahead and move on to number 4. It says how many type 2 LSA should exist in the LSA database for area 0. So it should be 0 because we don't have any Ethernet links. We're using serial point-to-point links. And with point-to-point links, a DR or BDR is not elected. If these were Ethernet connections, then a BR and BDR would be elected. But since we're using serial point-to-point links, that election does not need to happen because, like I said, we're using serial point-to-point links. So let's just verify that. Yep, it says right here, no network type 2 LSA should exist in the LSA database for area 0 because all links in area 0 are serial point-to-point connections. So that's correct. Let's go ahead and move on to number 5. It says on BB router 1, verify your answers to the previous step. So let's go to BB router 1 and we can do a do show IP OSPF database. And we can see that we only see type 0 router LSAs, type 1 router LSAs. We don't have any type 2 network LSAs. So that's perfect. It says on BB router 1, examine the OSPF link state database and compare it against the IP routing table to verify that the correct information was entered into the routing table. So let's do a do show IP route on BBR1, and we can see that we have this OSPF route learned right here, which is the 172.30.1.4, and it was learned via 172.30.1.2. So I forget which router that is. Let's see which router that is. .2. Yeah, so that is router 1. So it learned this route from router 1. So that matches up. So that's how I learned that BBR1 learned that route from router 1. Okay, let's go ahead and move on. It says from BB router 1, ping BBR2000 interface, which has an IP address of 172.30.1.5. So let's go over here. We're already here. Let's do a do ping. Let's do a 172.30.1.5. And we can see we have 5 exclamation points, which means this ping was successful. So that's perfect. Let's go ahead and move on to number 8. It says on router 2, router 3, and router 4, configure a loopback 0 interface. It says the IP address of each interface should follow the pattern x.x.x.x, where x is the router number, for example. Router 2's loopback 0 interface should have an IP address of 2.2.2.2. Use a net mask of 255.255.255.0, which is a slash, what is this, a slash 24? Yeah, this is slash 24. Yeah, so let's go to router 2. Let's hit tab. Let's do a configure terminal to go into global config mode. Let's do interface loopback 0 or loopback L0 for loopback 0. And let's do an IP address of, it said x.x.x.x, where x is the router number. So this is going to be 2.2.2.2, 255.255.255.0. Let's do a no shutdown to bring this interface up. Let's move on to router 3. Do the same thing over here. Let's do a configure terminal to go into global config mode. interface loopback 0, and let's do an IP address of 3.3.3.3, 255.255.255.0, and do a no shutdown to bring this interface up. Let's go into router 4. Let's do a configure terminal. Configure terminal, interface loopback 0. Let's do an IP address of 4.4.4.4, 255.255.255.0. Perfect, and no shut. All right, so we completed the steps for question 8. It says right here, configure each router in area 1 with a specific network command so that only the IP address or only the IP subnets on router 1 serial 02.1 and serial 0.2 interfaces, router 2 serial 00 interface and fast ethernet 1/0 interface, and router 4 serial 00 and fast ethernet 1/0 interfaces run an advertised OSPF in area 1 network. It says use 1 as the OSPF process ID. So let's start out on which router? You start out on router 1. Okay, so we're going to start right here within our written commands that we wrote out earlier in the lab. Let's do a exit, and let's do a router OSPF 1, and let's do a network of 10.0.0.0. Let's do a wildcard mask of 0.0.0.3 in area 1. Okay, and we need to do the next interface, which is the serial 0/2.2 interface. So that'll be network 10.0.0.4 0.0.0.3 area 1. All right, let's go ahead and move on to router 2. It has the serial 00 and fast ethernet interfaces that needs to be configured for area 1. So let's do an exit. Let's do a router OSPF 1. Let's do a network command of 10.0.0.0, a wildcard mask of 0.0.0.3 for area 1. And let's go ahead and do the fast ethernet 01 interface, which is to be a network of 10.3.0.0, and it should be a 0.0.0.255/24 for area 1. All right, and let's move on to router 4, and it needs to have its serial 00 and fast ethernet 0 interfaces to run in OSPF area 1. We just seen our adjacency come up with our syslog message, so that looks good. Let's go on and move on to router 4. Let's do an exit. Let's do a router OSPF 1. Let's do a network command of 10.0.0.4, net mask of 0.0.0.3 area 1. And let's do a network of 10.3.0.0 and a net mask of 0.0.0.255 area 1. All right, so that is the configuration right there for question number 9. It says on router 1, verify that the serial 0/2.1 and serial 0/2.2 interfaces are configured to run OSPF in area 1. So let's go to router 1, and we see our adjacency come up on router 4 as well. So that's good. It came up with router 1 and router 2. We can tell by their loopback interfaces right here. So let's go ahead and move on to router 1 and move on to question 10. It says verify that those serial interfaces are running in area 1. We can do a do show IP OSPF interface, and we can go down and we can look at the serial 0/2.1. We can see that it is running in area 1 right here. All right, so that's the first one. And we can look at the serial 0/2.2, and it is also running in area 1. So that answers question 10 right there. Let's go ahead and move on to question 11. It says on router 1, verify that adjacencies have been established with router 2 and router 4 in area 1. So we can do right here, we can do a do show IP OSPF adjacency. Oops. Okay, let me do an N. Let me do a show IP OSPF. Thought I can do an adjacency. No? Oh, neighbor. Yeah, that's what I meant to put, neighbor. We can see that we have a full adjacency right here with router 2. So we can tell that we have a full adjacency right here with router 2 and router 4. And we can confirm that these adjacencies right here as well within our show IP OSPF interface. So we can see for the serial 0/2.2, its adjacency is with router 4. And we can see that for this interface, serial 0/2.1, its neighbor is 2.2.2.2, which is router 2. So that answers question number 11. It says how many network type 2 LSAs should exist in how many network type 2 LSAs should exist in LSA database for area 1? So let's look. You should have 2 type 2 network LSAs because router 2 and router 4 both have Ethernet connections out of their fast Ethernet 0/1 interfaces. So let's confirm that. Okay, so I got that wrong. It says 1 network type 2 LSA should exist on what should exist for area 1. So we can confirm that. It says on router 2, verify your answer in the previous step. So let's go to router 2. I thought it would be 2 type 2 LSAs, but it's only 1. Let's do a do show IP OSPF, and we should do the database. Oops, if I can spell. All right. Yeah, we only have 1 network type 2 LSA, and that is coming from router 2. Okay, so we just confirmed that. Let's move on to question number 14. It says configure OSPF to run and advertise only the IP subnets in area 2 on router 1 serial 0/2.3 interface and router 3 serial 0/0 and fast Ethernet 1/0 interfaces. Use 1 as the OSPF process ID. So let's go over to router 1 first. Okay. Router 1. Let's click there. Let's do a configure terminal to go into global config mode. Let's do a router OSPF 1. Let's do a network of, let me put this back in the screen as well. For router 1, we need to do a network of 10.0.0.8, 0.0.0.3 for area 2. All right. For router 3, we need to do its serial 0/0 and fast Ethernet 1/0 interface. I'm not sure why Siri is coming up on my iPad. Let me go to router 3 and let's do a exit. Let's do a router OSPF 1. Let's do a network of 10.0.0.8, 0.0.0.3 for area 2. And we need to do the fast Ethernet 1/0 interface. Let's do a network of 10.3.0.0, 0.0.0.255 for area 2. All right. So it says how many network type 2 LSAs should exist in the LSA database for area 2. So I'm going to say 1. Hopefully that's correct. Is it 1? Okay, so it says no network type 2 LSA should exist in the LSA database for area 2 because only one device is present on the 10.5 .0.0/24 LAN segment. OSPF does not produce network LSAs for broadcast networks when only one device is present. So that makes sense. Okay, yeah, that makes sense. So we can, it says for number 15, it says, or number 16, it says on router 3, verify your answer in the previous step. So we're already on router 3. We just seen our adjacency come up with router 1. Let's do an end. Let's do a show IP OSPF database. And we can see that we have no network LSAs. We just have our summary LSAs, which are coming from router 1 because it's our ASBR or our ASBR area border router. And we have our router LSAs as well. Okay. Let's go ahead and move on to question 17. It says list the ASBRs in the network. But we only have one ASBR, which is router 1. So let's confirm that answer. Yep. It says router 1 is the only ASBR in the network. Let's go ahead and move on to question 18. It says observe OSPF process information on each router. Okay. Observe OSPF process information on each ASBR to verify your answer. What information indicates that the router is an ASBR? Let's go to router 1, which is our ASBR. Let's do a do show IP OSPF. And we can see it should be in this output somewhere. Just got to find it. Where is it at? It says, let me go through this output. It should be in this output. Where is it at? Yep, right here. It says for router 1, it says it is an area border router. So this confirms that this is an ABR. Okay. Conceptually, what does a router being an ASBR mean? So basically, an ASBR is between two areas. So for this topology that we have, R1 is the ASR for area 2 and area 1. It basically connects both of these areas back to area 0, which is our backbone area. When we're running OSPF, we know that all areas that are not area 0 have to be connected back to area 0. So for this example, area 1 and area 2 have to connect back to area 0, and they do through router 1. Okay, let's go ahead and move on to question 20. It says, can an AS or an ABR that is not connected to the backbone exist? No, it cannot exist. It says right here, no, an AS or ABR cannot exist outside of the backbone because all non-backbone areas must connect to the backbone. So I just explained that just a minute ago. So let's go ahead and move on to question 21. It says, on router 3, examine the OSPF link state database and compare it against the IP routing table to verify that the correct information was put into the routing table. You will use this output to answer the next two questions. So let's go to router 3. We already have our LSDB up right here. We can do a show IP route. Okay. And it says, where were the summary type 3 LSAs originated? So the type 3 LSAs, those should have originated from our ABR, which is router 1. So let's make sure. Yep. It says the advertised router ID is equal to router 1's router ID. So we know that these summary routes came from router 1. That's perfect. Okay, let's go ahead and move on to question 23. It says, how are summary LSAs identified in the IP routing table? They should be identified with this IA. So that means that they're coming from a different area. If we look at what IA means in this output, let's find where it's at. Where's IA? Let's find where that's at. Right here. It says that it's an inter-area route. So that means that it did not come from this area. It came from either area 0 or area 1. All right. So let's go to question 24. It says, on router 3, verify connectivity with 172.30.1.0, 172.30.1.4, 10.0.0.0, 10.0.0.4, and 10.3.0.0 using the ping command. So let's go to router 3. We're already here. Let's ping all of those addresses that it just listed. So those addresses are right here. I'm going to ping those right now. Let's do a ping to 172.30.1.5. That worked. Let's do a ping to 172.30.1.1. That worked. Let's do a ping to 10.0.0.2. That was successful. Let's do a ping to 10.0.0.6. That was successful. And lastly, let's do a ping to 10.3.0.4. And that was successful. We got 5 exclamation points on all of these pings, which means they were all successful. So that is the end of this lab right here. Let's go ahead and grade it. And hopefully we did everything correct. Okay, so we got something wrong on router 3. Let's see what we did wrong. What do we do wrong? So for this network, okay, so I configured .3. So I configured the network to be 10.3.0.0 instead of 10.5.0.0. So that was just a typo. We did the area and the subnet mask and everything else correct. Just a typo on this network. So let's go ahead and fix that. Let's go ahead and fix that. Let's go to router 3. Let's do a configure terminal. Config terminal. Let's do a router OSPF 1. Let's do a no network of 10. I think it was 10.3.0. Was it 10.3.0.0? And it should be 0.0.0.255 for area 2. We want to remove that. Let's do a network of 10.5.0.0, 0.0.0.255 for area 2. All right, now let's grade it. And we can see now that we got that configuration corrected. So this was a pretty long lab. I learned a lot in this one. Thank you guys for watching this one. I'll see you in the next one.